Hello, my name is Alexis, and in this video, I'm going to be showing you a little demonstration of LLaMA-Factory and how to use HuggingFace to fine-tune specialized models. Um, there's two ways specifically how I will be fine-tuning the large foundational models. Um, there is the direct policy optimization method called DPO, and then there's the proximal policy optimization method. These are both methods of reinforcement training, specifically reinforcement learning via human feedback. So to start, you import LLaMA-Factory. You would have to clone it from its GitHub repo. It is an open access repository, and you can install it very easily in Google Colab. I did have an issue, however, in importing the Python library called LLaMA-Factory. But the command line import works, so you can still train your models and import models via HuggingFace. However, there might be some issue with the Colab environment and loading the Python library. So if you want to, for example, at the very end, if you want to use the LLaMA-Factory methods to load the chat model, there might be an issue. I think there might be another way using the transformers. And if you want to, you can also use the HuggingFace CLI to upload your model, and then use the transformers library to pull it from HuggingFace separately, so that you don't have to build it with the LLaMA-Factory API itself. So there might be a workaround, however, I did have an issue loading the LLaMA-Factory. As you can see, there's no module named LLaMA-Factory, despite it showing it's installed in the Colab. So besides that, let's go ahead and show you the demo. So you would first need to authenticate with HuggingFace. You would need your own API key, and then after that, you can load the data. This is the identity data that LLaMA-Factory provides. They provide a lot of different sets of data, so when you would load it, it would be imported into your files here. However, I loaded this yesterday, so it's not loaded currently. It will take some time to train, so I trained it separately before to make sure it works. After you load the data, you would train it here. So I trained it on both the identity and the alpaca English demo datasets provided by LLaMA-Factory. LoRa is used to optimize training, and LLaMA provides a way to enable that, which is really nice. They provide a way to set a learning rate scheduler, which also is nice for device training using the GPU. Allows you to set a lot of hyperparameters within a JSON arguments file, and then you can reuse this to train different models. All you have to do is change the model name or path. And then you call it on the command line, and it will start training that model, and save it to your directory. And then once it's saved, then you can push it to GitHub or HuggingFace. Since HuggingFace is the version control of models, and after you initially train the supervised fine-tuning, which is considered the post-training. This model itself is already pre-trained. So this is supervised fine-tuning stage, which is SFT, and that's the post-training stage. And then after post-training, then you can do fine-tuning. And this is using the human preferences data. And this is where we get into reinforcement learning via human feedback. There's the DPO method, which is the simpler method, and it involves retraining similar to SFT. However, there's a change made to the data and the loss function. So you can change the stage DPO and then change the data that is being used. And then there's some other hyperparameters added. For example, here, pref beta, pref loss, val size. Similar to the initial post-training, you call LLaMA-Factory via the command line, and then it will start training the model and save it to a directory. Then there's the PPO method of fine-tuning, and this method is more complicated, as you can see here in the diagram. It has an evaluation stage, an optimization stage. It also has the initial training stage like in the previous method. And then the two models that are being used, there's a reference model and there's the active model. And then the PPO, what it does is it will sort of do contrastive learning where it trains both models and then has a reward to the active based on the reference, and iteratively tries to alter the training weights. So it's a little more complicated, so there's another stage added in this method. So you would have the reward model training stage, so you can set that here. You have different kind of data, the DPO and demo. The same model can be used, and then you would output it to the reward directory. This is a separate model entirely. And then you would train it again. After the supervised fine-tuning stage, both the DPO and the PPO would need to be supervised fine-trained after the model is loaded, even though it's already pre-trained. That's the post-training stage, and then here's the RHLF stage. Then in the PPO model fine-tuning, step 2, you would set the stage to PPO, and then you give it the reward model path to that model that was already trained. And there's also a difference in the hyperparameters. You would not have the pref beta or pref loss or val hyperparameters, since it is not training a reward model. This is the active model. And then you would train it. In this stage, it's using both models to train it. And then after that, then here's where you would load the model for inference to evaluate it. However, as I mentioned before, LLaMA-Factory package in Python is having some issues loading in Colab. So there was no real way to use this code provided by LLaMA-Factory to load the model using the LLaMA-Factory package. However, I did see that there was other ways where you could upload the model to HuggingFace and then load it using the commonly used transformers library to load the model. So yeah, there's room for improvement. However, this LLaMA-Factory package does provide a lot of functionality and is very interesting to use. So thank you for watching.